So the concentration problems. So if you have a chocolate fountain that has a 500-liter capacity, already has 20 liters of 70% milk chocolate. So you can set up your buckets. We're going to mix two things together to equal the total. So right now we have 70%. That's 20 liters of it. We're going to add a 90%, and we'll add X liters of it. And then we're going to end up with a final percentage, the concentration. And we don't really know how many we're going to have, but we're going to have 20 plus how many we add will be how many liters of that new concentration we have. So to get your equation, you just multiply 0.70 times 20 plus 0.90 times X equals C times 20 plus X. And we'll rewrite that as an equation solved for C. So solve that for C and you get C equals 0.7 times 20. I'm just going to write it out as that. I'll type it in the calculator later. Plus 0.9x over 20 plus x. There's the equation. So let's type this into our calculator. So go to graph. I'll do 0.7 times 20. Point 7 times 20 plus 0.9x divided by 20 plus x. Now, when you do this, you're not going to see anything on your regular window because your y values are your percentages, which has to be between 0 and 1 because it'll be 100%. Your x value is how many liters we're adding. The thing only holds 500, so let's go 0 to 500. So this is what the graph would look like. Now we can answer the questions using it. So sketch and label the graph. So a few things that you should know from being able to sketch this. You should know the y-intercept of it. And you actually know that without doing anything because the y-intercept will be the percent that it starts at before we add anything to it, because x is how much we added. So if we've added 0 to it, the percentage that we're starting with is 70%. So there's our y-intercept. If you want to check that out on the calculator, you just go gsolve with the y-intercept 0.7. Then as this goes, if you were to trace it, you can see that it starts flattening out, getting closer and closer and closer to, looks like about 90%, which also makes sense because that's what we're adding. The more of the 90% stuff we add, the less the original 70% stuff matters. But what matters a lot is when the tank is filled up, when the fountain is filled up. So if it started with 20 liters in it, How many liters can we add until it's full? It holds 500. Started with 20, so we can only add 480 liters. If you add anything more than that, it's going to overflow. So let's go out and find out what the 480 will give us. So it hits its full capacity when we have 480 liters, which gives us a percent concentration of 0.892. So that's up here at 480.892. And that's when this thing's filled up. There is a little bit of an asymptote that you could kind of draw here. That'll be at 90%. It's never going to pass 90 because we're not adding any percentages higher than that. So, sketch, labeled the graph. There it is. This is gallons that we've added. No, liters, sorry. And this is the percent concentration. What does the concentration approach as it's filled to its maximum of 500 liters? We know exactly what it approaches. It hits 89.2%. That's from the 0.8989.